Hey class, this is Gigi. I am going over written assignment number 16, question 1, part D. So we have a power series, and it looks like the center of this power series is at -3 because it's supposed to be x minus a, but here you have an x plus 3, so -3 really is your center. Okay, and then we are asking what is the radius of convergence, and then what is the interval of convergence. Okay, so interval of convergence, in order to answer that question, you need to check the endpoints. So first, in order to find the radius of convergence, we will either use the ratio test or the root test. In part D, I think I am going to use the ratio test. So I would say limit as k goes to infinity of a sub k plus 1 divided by a sub k. I'm planning ahead here. A fraction divided by a fraction is the thing multiplied by its reciprocal. On the numerator, I will have -2 to the k plus 1 times x plus 3 to the k plus 1 over 3 to the k plus 1 plus 1. That would be k plus 2. Here we'll take the reciprocal of a sub k. So 3 to the k plus 1 goes on top, -2 to the k power down here, and then I'll have x plus 3 to the k power. All right, so let's deal with the -2 first. -2 to the k plus 1 divided by -2 to the k would be -2. And then the answer value of -2 is going to give me 2. Okay, so far I have 2. Okay, then the 3 to the k plus first power on top, k to the 3 to the k plus 2 on the bottom. When you divide, you'll have 1/3. Or you would say 3 goes on the denominator. And the answer value of 3 is still 3. Okay? And then when looking at the x plus 3 to the k plus 1 divided by x plus 3 to the k, you will have an x plus 3 left. However, when we take the absolute value of that absolute value needs to stay because we don't know what x is. So when k goes to infinity, well, the k is not even there in question. So it will just be 2/3 of absolute value of x plus 3. And we need this to be less than 1. Okay, so you need this to be less than 1 for our series to converge, because that's what the ratio test will tell you. Okay, so you will say you want that limit L to be less than 1. That's what you want, right? So when solving now for x, because that's what the question is, to go and solve for x, you would say then multiply by 3 divided by 2. We would have answer value of x plus 3 has to be less than 3/2. So your radius of convergence is going to be 1.5, or 3/2. That's your radius of convergence, 1.5. Okay, or if you really think about this here, you'll have x plus 3 gonna have to be less than 1.5 and greater than -1.5. Subtract 3 to both sides. We will say this right here is going to be -1.5, and this right here is -4.5. So these are the numbers here, -4.5. This is -1.5, which means you have gone out from the left and to the right of -3, 1.5 units. That means the radius of convergence is 1.5. Okay, now in order to find the interval of convergence, we want to know what happened at the endpoints. So we will have to go and check at the endpoints. So when x is -4.5, what do we have at the endpoints? We will have the series from 0 to infinity, -1 power. I'm going to, instead of writing -2 to the k power, I'm just going to go ahead. Oh, actually, I can just write -2. It really doesn't matter. To the k power. And then I'm going to write -4.5 plus 3 is going to be -1.5, which is -3/2 to the k power, all divided by 3 to the k plus 1 power. Okay, now if we really think about it here, this can be broken into -3 to the k power divided by, I'm going to put the negative with the -2 to the k power. So that's going to cancel out with that. That is gone. Okay, so I mean, not really gone. It really is 1, right? When you divide, you get 1. And then k to the 3 power, 3 to the k power divided by 3 to the k plus 1 power is going to have a 3 left on the denominator and the 1 on the numerator. So this is being replaced by that, right? So really, this series is going to just be the series going from 0 to infinity of 1/3. Well, what happened when you take 1/3 plus 1/3 plus 1/3, and if you keep adding 1/3, well, it's going to get big, right? So this series is going to diverge. Okay, now when x is -1.5, the other end. So this end right here is an open circle. Okay, and let's go and take a look at the other end. When plugging in -1/2 instead of -3/2, you have -2 to the k power, and here you'll have 3/2 to the k power divided by 3 to the k power. The same process will apply. However, the -1 is going to stay, and that would be -1 to the k power divided by 3. Okay, so this series is looking like this. It's going to be 1/3 minus 1/3 plus 1/3 minus 1/3, and so on. So the sequence of partial sum is going to start at 1/3, and then it's going to be 0, and then it's going to be 1/3, 0, 1/3, 0. So the partial sum is bouncing from 1/3 to 0, right? The SN is bouncing between 1/3 and 0. So we say that this series diverges as well. So no endpoint here either. That's open. So our interval of convergence go from, oopsie, not sure why that erases, but that interval of convergence go from negative, well, it's not happy that I do that. Go from -4.5 to -2.5. So to answer this question, we would say the center is at A equals -3. The radius of conversion is 1.5. And the interval of convergence is going from negative 4.5 to positive 1 and to negative 1.5, and it is open at both endpoints. And that is the final answer for this problem 1, part D.